Alrighty then, corn children. Today's lesson is Pascal's triangle. I suppose that should be a apostrophe. Pascal's triangle. What is it? How do you make it? And unfortunately, not in this video, but coming to a theater near you soon, what do we use it for? So for today, it's kind of an introduction to what is Pascal's triangle, how do we create it, and then we'll go from there. All right, not surprisingly, the shape of Pascal's triangle is a triangle. I know, right? So in order to help you out, I have made a visual aid. Stay with me here, people. Here we go. Yeah, it's a triangle. It is a triangle of toilet paper. Yes. Now, on each roll, we are going to assign a number. There's a very specific pattern to this. It's not that difficult. You'll pick it up right away. All right, so at the very point, the peak, the apex, if you will, of the triangle, we are going to assign a number. On the top, you automatically give it the number 1. The rule is, on the outer edge of Pascal's triangle, you always assign it a value of 1. So the exterior edge of Pascal's triangle is always a 1. Now, what about the interior numbers? How do we get these interior values? Well, it's again a very simple process if you're building Pascal's triangle from the top down. Any interior number can be found by adding together the two numbers that are diagonally above it. So the last time I checked, 1 plus 1 is 2. And sure enough, this roll is assigned a value of 2. Now here, we would need to add the two rolls that are diagonally above it. So 1 plus 2 would make this a 3. Here, same thing, and of course there's going to be a symmetry on the triangle. We would add 2 and 1 to get a 3. Now that's a pretty simple process. But obviously, if we wanted to make a larger triangle, we would need more toilet paper. And unlike many of you, I did not go and hoard all the toilet paper at Costco. So instead of using more toilet paper, I suppose we could just go back to paper and pencil. I know, but the toilet paper was fun. And if you are a hoarder, feel free. So going back to paper and pencil, and you'll notice in your Google Classroom lesson, I have provided you with the triangle worksheet. So that will help you out and you can play along that way. All right, let me get my toilet paper out of the way here. So, Pascal's triangle. Once again, here's your idea. At the top of the triangle, you place a 1. On the outer edge, you automatically assign the value of 1s. But for the interior values, you would need to add together diagonally to get those values. So I'm going to do these real quickly. 4, 6, 4, 5, 10, 10, 5, 1. And then 1, 6, 15, 20, 15, 6, 1. All right, you will also notice on your worksheet that each of these rows has been assigned a value. Now this is a little bit tricky, not a lot. The first row is not row 1. The first row is assigned row 0. And there's going to be a reason for this. We're going to look at it here. But that is row 0. Row 1 is here. Row 2 is the row 1, 2, 1. row 3, 1, 3, 3, 1. Hey, check this out. If you're in row 3, the second number is 3. When you're in row 4, the second number is 4. When you're in row 5, the second number is 5. There's a pattern. Matter of fact, this thing is chock full of patterns. There have been books written about the patterning just found in Pascal's triangle. Feel free to enjoy some of that. Just one pattern real quickly. 1 plus 2 plus 3 makes 6. 1 plus 2 plus 3 plus 4 makes 10. So there are all these little interior patterns as well. But what if we wanted to do the 7th row of Pascal's triangle, but we didn't want to have to make the whole thing? Either we're out of toilet paper, or we are out of patience, or we don't want to have to make a giant triangle. Is there a way that just freestanding that we can crank out row 7 without doing the whole thing? And of course, if I ask for row 7, I could easily ask for row 17 or row 70 or row 50. I can do any row I want. Can I generate these all at once? And the answer is yes. We use combinations. Now, if you have not watched the video on combinations, stop right here, go back, watch that video, and then come here, because we're going to use combinations. As it turns out, this number 1 can be thought of as, actually, row 1. Okay, this number here can be thought of as 6 objects chosen 0 at a time. You have 6 pens, you want to choose none of them. How can you do that? Well, there's one way, choose nothing. So this number can be thought of as 6 choose 0. That's the NCR notation. This would be 6 choose 1. 6 choose 2. 6 choose 3. 6 choose 4. 6 choose 5. And 6 choose 6. Again, notationally, this represents if you have 6 things and you choose all 6 of them, there's only one way to do it. Choose them all. Done. This would be you have 6 items, you're choosing 5 of them. There's 6 different ways to do that. Each time you could leave out a different item. So these are the combinations. So if I wanted row 7, I would just need to change these to 7 choose 0, 7 choose 1, 7 choose 2, 7 choose 3, and so on and so on and so on. And so, to get the 7th row of Pascal's triangle, I could enter all of those values one at a time. Or I could be really wise about it. Yeah! We are going to be able to generate the 7th row using our graphing calculator. All right, pause the video if you need to. Go get your graphing calculator. All right. The first thing that we're going to do on our graphing calculator is turn it on. Excellent, good start, awesome. All right, the next thing that we're going to do is we are going to go to our y equals menu. The y equals button is here. I've used mine so much there's nothing left on it. And we are going to enter this value. All right, so this is row 7. If you want row 7, you put a 7 here. NCR. And the variable x. I've used my variable key to get that x there. Once again, if you need to go back to the other video, this is found under the math menu, under the probability submenu. All right, so I get that in my y1. Excellent. Now I'm going to have the 7th row show up in the table. So in order to do that, I need to set up my table. So I will need to go to the French button table set. No, that's short for table setup. All right, it's in blue, so we use our 2nd key, we use our table set key, and here we are. If you need to, pause the video, but you're going to want to start with 0. You want the delta value, how much it goes up to be 1, and you want both of those on auto, so it automatically enters everything for you. Awesome. All right, next up, we're going to look at our table. So right here's your table key. It's above the graph key. So 2nd key, table key. All right. 7 choose 0 is going to be 1. 7 choose 1 is 7. Then these numbers. Now it goes off the screen, so you have to scroll all the way down to 7 to get the final value. Remember that the rows begin and end with 1, so you don't have the full row until you see the 1. If you go any further, it makes all zeros, so that kind of also will tip you off that you are off the table. So it's the non-zero values. And there we go. The 7th row of Pascal's triangle. For those of you who don't have the graphing calculator, just a side note here, the Desmos Online, the free graphing calculator, has an NCR feature under the function submenus. So if you look around under the function submenu on Desmos, it is in there. You can create a table. It's a little bulky. You may just want to enter them one at a time. 7 choose 0, then 7 choose 1, 7 choose 2, and so on to get your row. All right, so at this point in time, you should be able to create Pascal's triangle, either starting from the top and working your way down, or by using your graphing calculator, generate any row, whether it's freestanding or not. And sure enough, we can figure out our values here for the 7th row. 1, 7, 21, 35, 35, 21, 7, 1, which is exactly what we got. Awesome.